Hi, welcome back to Moose in Chemistry. This is electron configuration of calcium, Ca. Now, calcium is the 20th element of the periodic table, so we're going to write a 20 right here for our atomic number. Calcium's AMU, or mass number, is 40. Okay. So now, if it has an atomic number of 20, that means it has 20 protons. And since calcium is electrically neutral, it would have to have 20 electrons. What about the number of neutrons? Well, we look at AMU minus protons equals the number of neutrons. Okay, so that would be 40 minus 20 would give me 20 neutrons. Pretty snarly, eh? So we're just going to put a 20 there. But before we do the electron configuration, we have to look at a couple things. S subshell can hold 2 electrons, P subshells can hold 6 electrons, D subshells can hold 10 electrons, and the F subshell can hold 14 electrons. We're also going to use the diagonal rule right here. And what we're going to do is we'll start at the top of this red arrow, and we're going to work our way down until we run out of electrons following the arrows. So let's go ahead and do the electron configuration. So we got 1s2. Okay, so we're going to slide down again here. This would give me 2s2. Pretty easy so far, huh? 2p6 and then 3s2. So far, so good. This is amazing. All right, then we come back to the top of the slide. We get 3p6, and then we go to 4s2. Now, we're going to stop there because if you look at this, 2 and 2, 6 and 2 and 6 and 2 make 20. All right, that's pretty cool. Now let's look at our orbital notation. Orbital notation deals with Hund's rule. Hund's rule states that for every sublevel, you have to put an up arrow first before you put the down arrow in it. So let's look at 1s. It only has one sublevel, so we go up arrow and then down arrow. Same thing with 2s, just one sublevel. Up arrow, down arrow. But with 2p, we got 2px, 2py, 2pz. So you're going to go up arrow, up arrow, up arrow. Then we're going to go down arrow, down arrow, down arrow. Pretty darn snarly, huh? 3s, one subshell, up and then down. Pretty cool, huh? So 3px, 3py, 3pz would be up arrow, up arrow, up arrow, and then down arrow, down arrow, down arrow. And the 4s2 would be up arrow and then down arrow. Now, let's look at our noble gas notation. What's the nearest gas to calcium that's noble? Well, of course, it's going to be argon, right? So we're going to use argon as our noble gas. So put Ar in there. And let's look at our valence shell, the last possible shell that can hold electrons. That would be argon 4s2. That's pretty easy, huh? Okay, what about our quantum numbers? Well, what is the N value? In essence, what period does calcium reside in? Well, calcium is in period 4, so the principal quantum number would be 4. But notice that calcium is in the S block, right? So the angular momentum number would be 0. Same thing with our magnetic number. It's in the S block, so the value is also 0. I'm going to put a 0 right there. Now, look at the last arrow. It's going down. So that means our value is going to be 1/2 negative. Well, that's it. You guys be snarly, and we'll see you back here at Moose in Chemistry.